Session is about space stations. Vibhu Unnikrishnan sir, a scientist and engineer from VSSC, is going to share more interesting facts about space stations. Through this session, we get more knowledge about space stations, pivotal role in advancing human space explorations, experiments held at space stations, etc. It's a great opportunity for all of us to participate in this session, so utilize it. We have certain instructions for the participants. Keep your microphones muted at all times during the session. Ensure your camera is off unless asked to turn it on. If you have any doubts or on questions, they can be shared in the chat box with your name and class. They will be read during the questionnaire session. Please ensure questions are relevant to the topic. And my name is Unnikrishnan. I am from Kozhikode. Thank you.
Adidev, you can go ahead.
A very good afternoon and a warm welcome to all fellow space enthusiasts and dignitaries here today. My name is Adidev. I'm an 8th standard student of Devgiri Semi Public School, and I would like to welcome all of you to the 74th session of the UN Space Club webinar series. Since its inception during the 2020 COVID lockdowns, this series has gone on to host various intellectuals of science. Today's webinar by Shri, Vibhu, Unnikrishnan sir will be an overview on space stations. As we all mostly know, the Union Cabinet recently approved the construction of our very own space station, the first model slated for launch in 2028. So space stations are a very relevant topic of discussion in our country. Vibhu Unnikrishnan sir is a scientist and engineer at VSSC Thiruvananthapuram and a graduate of NIT Calicut. This session here today is sure to enlighten and teach us all a great deal about space stations. I wholeheartedly welcome you, sir, to this webinar session. I would also like to warmly welcome our esteemed founder and mentor, E.K. Kutty sir, to the session, along with all other distinguished mentors like Jairam sir, Sundaramurthy sir, etc. present here today. I welcome our moderator, Shri sir, along with our student coordinator, Varnatan. Last but not least, I would like to welcome all of you, the students present here today. The desire shown by all of you to attend today's webinar is one of the passion you all carry for science. I now call upon Shri sir to officially introduce our speaker. Thank you.
Thank you, Adidev. We have been here for the 74 sessions. It's a 73rd session already over, and now we are in 74. And it's still we are wondering how it's happening there, and we are connecting these students. And even though it's the exam time, there is enough students are with them, and a few of them will join soon with us. And we came with a new topic in this session, space station, an overview. International Space Station, it's very familiar for us, and some of our students, when they were kids, might have seen and observed and a little bit curious about these ISS. Now we are a little bit concerned about the Indian origin astronaut Sunita Williams. She is there. We are a little bit concerned about her. And today we get an opportunity to know more about these space stations from a young scientist from Vikram Srabhai Space Center, Mr. Vibhu Unnikrishnan. He is a graduate from NIT Calicut and MTech in design engineering from BITS Pilani Pune, and he has been in ISRO since 2015, and now he is playing instrumental role in multidisciplinary product engineering division of VSSC. He worked with polymer systems and thermal protection and insulation of large vehicles, and still more contribution is awaiting from his side to this great institution of India, ISRO. And I formally welcome today's speaker, Vibhu Unnikrishnan, for his talk, and all the veteran scientists and students and teachers who gathered here to hear this talk. And after his talk, there is an opportunity for the student to interact directly to these scientists. And without taking much more time, I wholeheartedly welcome Mr. Vibhu Unnikrishnan for his talk. Welcome, sir.
Thank you, sir. So, shall we start?
Yes, sir. Yes, sir.
Okay, sir. I'll share my screen. Is the presentation visible?
Okay, it's okay, sir. It's okay.
Yes, sir, it's visible.
Okay. So today we are going to talk about space station. So this is a very complex and a wide topic. So I will be giving a brief overview of what is a space station, what are the important technologies involved in making a space station work, and a brief history of the space station and how it is going to be in the future. So first we can see what is a space station. So basically a space station is an orbiting spacecraft which is capable of sustaining human life for extended duration. So for sustaining human life for extended duration, we have to have certain systems like environmental systems, thermal protection and radiation protection systems, food, personal hygiene systems, etc. in a space station. These platforms, unlike satellites are remotely controlled and they autonomously work or in the orbit, capturing images or making measurements of either the Earth or the outer space. But space station is a unique place where it will provide an opportunity for human beings to actually be there and study the space. So we can experience microgravity, carry out research in microgravity, and understand how we have come into existence. So here we can see the several space stations which have existed over the years. So this I will again come back in the later slides. But as we can see, the Salute 1 was the first space station. Then there was Skylab, Mir, ISS. Then China started launching their own space station. Tiangong 1 was first, then Tiangong 2, and now there is a bigger Tiangong space station launched by Chinese. So why do we need space stations? So this is a question we need to ask. To make a space station, we have to put in a lot of work, and moreover, there is a lot of money involved. So, and why not solve our problems on Earth rather than why building a space station outside Earth? So to understand that, we have to see certain examples of how the space station, the research carried out on space station has been useful to us. So I'll play 1 or 2 videos and you can also understand. So here we can see how water molecules are behaving in space. So this research, if we do it on Earth, we cannot and never simulate it one-to-one as what will be the behavior of water molecules in microgravity. This has many dimensional impact because due to the gravitational force, there will be always some anomaly that happens during several processes like crystal growth, etc. on Earth. So these processes can be studied independently to have a better understanding of how this would have happened when the planets, as we know today, might not have existed. Now, another important thing is Earth observation. We always see satellite images, even when floods, cyclones are coming, we have satellites which will give us advanced warning as to when such unwanted incidents is going to happen. Similarly, when we are having a space station, we can have a 24/7 coverage of Earth surface to understand in real time what are the changes that happens on that surface. So we can see a short video from ISS which shows how when it goes around Earth, how it sees Earth. So similarly, we can have several scientific payloads on a space station. Unlike other spacecraft, the advantage of the space station is whenever we have a space station, there will be manned missions or cargo missions which will go from Earth to space to send some items from Earth to the space station, as well as collect some items from space station and bring it back to Earth. So whatever payloads are the experiments which we have on a satellite or the space station. So whatever payloads we have on the space station, we can do the research, bring it back to Earth, and have a detailed study here to understand how the space radiation, microgravity, thermal environment in the outer space is affecting the payloads. So here we can see there is an experiment called Ecosystem Spaceborne Thermal Radiometer Experiment. So it is called EcoStress instrument. So this records the temperature of the plants on Earth's surface by measuring the heat they give off. So this is a very important information to understand what are the changes that is happening to the plant growth over the years. Similarly, another experiment which is Global Ecosystem Dynamics Investigation, JEDI, it is creating a 3D map of the world's tropical and temperate forests. So with the climate change, what is happening to the plants and forests around Earth, whether the height of the plants are going up, going down. And this information captured over the years will give us a very good understanding of what is going to come in the future. And this will help us in making countermeasures and improving our understanding of how our Mother Earth is changing. There is another part is this. So far, whatever experiments we have seen is looking towards us back to Earth from space station. Similarly, we have payloads which look from the space station to the outer space. So here we have a video of a neutron star interior composition explorer NICER payload, which shows X-ray boost linked to the Krabs pulsar star. So here we can see that short video. So these are only a minuscule of the scientific data we are generating by having a space station. So if we go see, so for having a space station, unlike a satellite, we need human beings on the space station. So this requires, this will have, whoever is the human beings going to be on the space station, the space is going to have a very impactful effect on their circadian rhythm, their medical condition, their psychological condition, and their physiology. So if you see here, what are the challenges associated with staying in space? We have listed a few of those here. One is altered immune system, temperature change, celestial dust exposure to contaminants. So these are kind of changes which are happening due to the lack of atmosphere in space. So what we have to have is, we need to have a good environmental control there with a routine cleaning, air quality monitoring, and thermal control system and immunization. Then, since they are far off from Earth, there will be a difficulty in providing healthcare. So we cannot have all the medicines taken up there, and we cannot always have a specialist doctor there. So all these things needs to be done through online consultation and monitoring. Also, food, we cannot cook food like we have here, sometimes food what we have here on Earth or in space. So we have to take preserved food and reheat it and use it there. Then radiation is a very heavy risk which we have in space stations. Like we have shown in the previous slide, there will be radiation coming from certain stars. Even our sun gives up so much radiation, which causes degenerative diseases and radiation sickness. So for this, we need to have radiation shielding and continuous health monitoring. If otherwise, no, there will be impacts such as cancer and nervous system damages. Then, like I told, there will be more importantly like psychological changes, because no, since they are far away from Earth and separated from their loved ones, there will be a lot of behavioral change, that sleep problem and fatigue. Sleep problem is another unique condition in space, because in Earth we have a defined day and night. But in space, especially in space station, which has an orbital time period of around 90 to 95 minutes, they will have around 16 sunrises in a day. So there is nothing like a night or day there. It is always continuously changing. So their circadian rhythm gets affected, and they need to actually prepare themselves mentally and settle to a stable routine to have enough sleep and maintain their health. So we are classifying the effect of space on human beings into short-term effects and long-term effects. We can have like short-term effects are the space adaptation sickness, readaptation when they come back to Earth, then stress, fatigue, nausea. Basically, when they are there, they will have a lot of stress due to psychological factors. Also, they will be continuously working. Nobody goes to space station to take a vacation. So this also produces stress in them. Then during the flight to the space station, it is one of the most severe effects of gravity will be acting on the bodies of the astronauts. So during this time, most of the fluid will be pumped to the legs of the astronauts from the head, which can lead to even blackouts. Then as a long-term effects, what we have seen is there will be cardiovascular reconditioning and muscular atrophy. So what happens is, since there is no gravity, our body, by God's grace, it has the capability to adapt to a lot of situations. Like if we see how we have evolved over the millions of years to the organism we are today, when we go to space, our body understands that the muscles needed to lift objects or to do heavy exercise here are not required there. So that causes a reduction or degradation of the muscular mass of the body of the astronauts. So in order to maintain this prevent this muscular atrophy and maintain the muscular mass, they have to do continuous weight training. Then bone mass loss will be there. Then, like I told, due to radiation and other effects, there can be cell damage and cancer. So as a countermeasures, we have low resistance, high frequency exercises. Means every day they will have several, they will do exercise in several shifts. Then high resistance, low frequency exercises. Then lower body negative pressure. Then pharmaceutical support through vitamins and other tablets. Then in certain space stations, we have artificial gravity systems. Then once they come back, they need to have sufficient fluids in their body to prevent blackout and unconsciousness. So these are some of the countermeasures which we have evolved in this area from the years of experience which we have. Then another important part is crew selection and training. So the crew must go rigorous physical, psychological, and technical training. So coming to a little detail regarding the muscular atrophy and the flow of fluids from our head to our toe. Basically in a space station, there is no up or down, because since there is no gravity, there is no top or bottom or means the floor or ceiling. So everywhere is like same. So that will cause disorientation to our brain. Then once we are reaching this phase, since unlike in Earth where the gravity, our heart has to pump to send the blood to our brain, there is much lesser effort required for the heart to send fluids to our brain. So as a result, when we have a heavy rush of blood to our head, we feel lightheadedness, and our face will become puffy, etc. Then, like I told earlier, Andy, this due to the non-usage of muscles, we actually lose the muscle mass, and our legs and hands become weak. And since the effort required by the heart also comes down, fluid volume decreases, etc., also happens. Then, if we classify what are the impacts and what are the systems that require to keep astronauts safely in space, that is a combination of aeromedical systems which take care of the fitness and health. Then, man-machine systems, which is required for running the operations of the space stations in a smooth, seamless manner. Then there are psychological aspects, physiological aspects such as microgravity, acceleration, vibration, and radiation, which is there in space. Then psychological aspects of feelings of being away from Earth, isolation, and distress. Then how we give them resources like food, water, nothing is there, right? So we have to take each and everything must go from here to space station for the astronauts to have. So the food and water, medical care, oxygen, even the waste management, how we usually dispose of the waste from space, that is also a big challenge. So summing up now, if we see what are the main key technologies required for having a space station, first we need to reach orbit. So towards that we need a human-rated launch vehicle. And second, once we reach there, for us to have be alive, then we need a good environmental control and life support system. Then for communication, today we are living in a world where each of us are very much attached to our mobile phones. But more importantly, when we are in space station, we need to have 24/7 communication with the astronauts to monitor them and support them in case of emergencies. In space, we do not have second chances. So one catastrophic happens, then there is no turning back or salvage option. So we need to be always aware, monitoring the situation, and take precautions and countermeasures. Then we need spacesuits and associated systems for the astronauts to be safely staying in the space station and going out for spacewalk. So for going out for spacewalk, we need a way for the astronauts to come out of the space station without degassing the entire space station. As you know, out in space, there is absolute vacuum. And in the space station, we are maintaining an atmosphere of one atmosphere, similar to what we have here on Earth. So when they open a door, within seconds or microseconds, the entire air will be sucked out and the space station will depressurize. So if you want to take an astronaut out of the space station for an extravehicular activity, we need to have systems that prevent such things from happening. Then for going in and out of the space station through vehicles, like a spacecraft going here from Earth to the space station and coming back from space station to Earth, we need systems such as docking and berthing. I will detail what are docking and berthing systems in my further slides. Then we need power. Like Earth, we need power. So unlike in Earth, we don't have rivers or coal in space. So what we rely entirely upon solar power. And what are this power we have to have? Like I told, we are having around 16 sunrises in a day. But in this 90 minutes orbital period, there will be certain times when there will be no sunlight. So during this time, we cannot have a power cut inside the space station. So we need to have a battery or energy management system which will store the energy from the solar panels and use it when there is no sunlight. Then we always need to have a guidance, navigation, and control. As you will see, now there are a lot of objects in space. So whenever the space station is there, we need to always navigate through to navigate, to avoid these kind of collisions with other objects in space, as well as keep a track of how our orbit is being maintained. Sometimes when in space station, what happens is Earth's atmosphere is, as we know, is there up to around 100 kilometers, but over and above that also, there will be a certain amount of a very thin atmosphere present. So it will cause a drag on the space station. So this drag will reduce the altitude of the space station, and it can come crashing down back onto Earth. So to prevent that, we have to monitor the orbit, and whenever required, we have to raise back the orbit to the higher level. Then there will be thermal management and radiation protection system. So what this means is radiation, as I told, is from sun and other stars. There will be severe radiation and bursts coming. So we have to have a way for preventing this radiation from coming and affecting the astronauts on board. Then there will be heat dissipated by the body of the astronauts, as well as electronic packages on board space station. So we need to have a thermal management system for preventing overheating of the space station or overcooling of the space station. Then now in today's world, we need to have a good robotic system, especially in space stations. We have only limited manpower, maybe 3 people, 6 people, 10 people. So there will be certain jobs which may require some heavy lifting. So, and we have so many limitations, especially when we are outside the space station. So for these robotic systems are the best friend of man there. Then there will be human-centric systems like personal hygiene management system, crew quarters where the astronauts sleep, food, etc. Then another key technology is astronaut selection and training. It is very important who we send up there. We cannot have a rogue person there or a person with a very low psychological breakdown level, whom we cannot have a trust to execute his duties within the stipulated time in orbit. So for that, we have to select the best people among us and send them up there. So I will go through each of the key technologies one by one. So coming to the launch vehicle system, as we know, we have several launch vehicles today for launching satellites to space. But unlike these launch vehicles, human-rated launch vehicles are required for launching crew. So what does this human rating mean? Human rating means we need to build in more reliability, safety, and measures for crew survivability in case of any inadvertent abort or malfunction. So it will have systems like crew escape system, higher amount of redundant channels. If there is one communication channel given in a normal launch vehicle, we may have 2 or 4 communication channels in a human-rated launch vehicles. This is required in case, because of electronic systems like our mobile phones, one day suddenly one line will appear on the screen. Similarly, anything can happen anytime due to we cannot predict when an electronic system may fail. So we need to have redundant channels to ensure that even with any single point failure will not affect the safety of the mission. Then we need to have systems when humans are going, we need to have oxygen and other ambient environment suitable for humans while going up. Then they needs to have several validator, and we cannot have a human beings put on a new vehicle and suddenly we cannot lift off and see if this will work. We need to have several unmanned missions and other rigorous ground tests to ensure that these systems are robust enough so that a human being can be transported in such a system. Unlike our cars, which will not have such kind of requirement, our launch vehicles need to be ensured that it has a reliability of greater than 99.99% to take a human being on board. So this is one of the activities which currently ISRO is also pursuing as part of Gaganyaan. So that's why we are having a lot of work to be done to human-rate our launch vehicle, our launch vehicle Mark 3, GSLV Mark 3, which will be taking the astronauts to space. We are in the process of so currently, these are the human-rated launch vehicles which are available and being used for carrying crew to space station and other orbits. So there are 2 governmental vehicles. One is Soyuz from Russian Space Agency and Long March 2F from Chinese Space Agency. And over the last few years, several private players have come up with their own robust launch vehicle systems like Falcon 9 from SpaceX, New Shepard from Blue Origin, and Atlas from from the United Launch Alliance. So these launch vehicles have the redundancies and the durability built into them, and has proven through ground test and over the many flights they have had so far to be useful, safe enough for transporting human beings to space. Then another key technology is the environmental control and life support system. So this is a basic flowchart of how an environmental control and life support system will be working. So it requires